this.
You said no, there's still time left on the timer.
Maybe. So up at the top, I kind of punched a hole in it, and I didn't need to, but it says you're going to use your graphing calculator, you're going to find these, and you're going to round to the nearest 10. So on this whole worksheet, we're going to round to the nearest 10. So I'm just plugging this in my calculator. So
Log 5.
Log 5.
Log 50.
0.69.
And I'm rounding to the nearest 10.
So 0.7.
Yep. Log 50.
7. We'll just use 7. 1.7.
Log 100. Alright, so now they want us to take these logs that are written in this column right here, log 5,000, log 500, log 250, and they want us to rewrite them in terms of 5, 50, and 100. So they did the first one, they took log 5,000, and they rewrote it as log of 50 times 100, because 50 times 100 is 5,000. So 5, 50, and 100 are the only numbers that I can use. So how am I going to rewrite log 500?
Log 5 times 10. No.
Yeah.
10's not a choice.
5 times 100.
5 times 100, yeah. So I'm going to do log 5 times 100.
Then the next one's log 5 times 50.
The next one will be log 5 times 50. 5 times 50 gives you 250. All right, so on this next one, I need log of 20. And the only things I have to... Yep.
100 divided by 5.
So I'm going to do 100 divided by 5. So I'm going to do log 100 divided by 5. How would I get log 2?
100 divided by 50.
So log 100 divided by 50. And log 10.
50 divided by 5.
Log 50 divided by 5.
Does that change the answers that you get?
Nope. All right, so now we actually are going to put it in our calculator in a bad way.
Log 5,000.
So log 5,000. And rounding to the nearest 10.
Wait, so every 0 that you put on a 5, it makes it go up 1. Because 5 was 0.7, log 50 was 1.7, 500 is 2.7, 5,000 is 3.7.
You got time. Can you reset quiz 1?
Yeah.
So that means for
Should be. Okay, so now on this last column, they want us to rewrite our solution. So on the first part, we rewrote our argument. The argument was 5,000. We wrote it as 50 and 100. Now they want us to rewrite our solution in terms of 0.7, 1.7, and 2. So in this case, 3.7, I could get that
2 plus
from,
1.7.
yeah, 2 plus 1.7. And 2.7,
2 plus 0.7.
2 plus 0.7. 2.4, 1.7 plus 0.7. Okay, what about 1.3? 2 minus 0.7, 0.3,
2 minus 1.7.
2 minus 1.7, and 1,
2.
1.7 minus 0.7. All right, so now, look at this column and this column, and see if you see a pattern. What's happening here?
The first three are the same operation, the second three are the same operation.
Yeah, the first three are the same operation, and what operation are they in the logarithm?
Multiple.
So if they're multiplying in the logarithm inside of the argument, what do we do with the solution?
Add.
Yeah, and if we were dividing inside of the argument, what do we do with the solution? Subtract. So in this case,
Wait,
Original table.
but the
Multiply.
But the third one is division and addition.
third one, this one?
Oh, but you have to cut the example too.
Oh yeah, I did that earlier too, because it's, this one's multiply, 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 and then divide, divide, divide.
I was okay with multiple.
So multiplied arguments, remember that's the stuff in the parentheses by the log.
I just spelled argument. What did you print out?
That
I know.
they result in added solutions. Whereas divided arguments result in subtracted solutions. All right. So now let's look at a couple of other patterns. So down here, we all agree that 5 squared is 25, and 5 cubed is 125, 5 to the 4th is 625, right? So they went ahead and they squared it and all that stuff for us. So let's go ahead and evaluate these in our calculator. So log 25.
1.4.
All right, so at the top of the page, we found log 5 to equal 0.7. So 0.7 is the solution to log 5. So how do these solutions relate to 0.7? How does 1.4 relate?
Double.
Yeah, it's double. It's 2 times 0.7. And what about 21?
3 times.
3 times 0.7. And 4 times 0.7. 5 times 0.7. And 6 times 0.7. Now, look at the pattern. Compare the last column to the very first column.
That's the same as the square. Or the exponent.
It's the same as the exponent, right? The solution is multiplied by the exponent.
Is this possible?
One.
You divide by 5.
Well, we're ready to go home, boys.
Just, okay.
Must be nice to
Did
get to
you-
go home.
Did you raise the power already?
Yeah.
I rose the power from here to 4 times 5, 20. And I applied 5.
I got my guess.
Oh, hold on, this is 5 to the third. 3 to the 5th isn't.
Oh, you made 3 to the 5th.
Yeah, 3 to.
Oh.
All right, so you just saw the properties of logarithms in action. So we're gonna talk about what they are. So the first one is the log of a product is equal to the sum of the logs of the arguments. Now that's a lot of big talk, but what it really means is, if you have an argument like this one, visually see that what's inside of the argument is being multiplied, then you can actually split that into two simpler logarithms by addition. So this would be log base b of x plus log base b of y. And the reason we do that is that sometimes it makes our problems easier. You'll see in tomorrow and in the next couple of days why we do it. All right, so this one says the log of a quotient, that's division, is equal to the difference
So it means
of the logs of the
subtracting.
arguments. Right, so in this case, inside of my argument, they are being divided. So I can split this one logarithm into two simple logarithms with subtraction. Now with subtraction and division, order matters. So whatever's on top has to be listed first. So it's going to be log base b of x minus log base b of y. Alright, then this one, the log of a number raised to a power is the same as the coefficient of the log of the argument. So what that means is anything that's up here in the treehouse on an argument can be moved in front of the log to be its coefficient. So this would be p log base b of x. So that was an exponent, now it's in front as a coefficient. This is what logarithms are all about, getting things out of the treehouse and down onto the line. So similar to that last rule, but before we get to that, let me talk about this one for just a second. Right here, we revisit when we very first started reviewing exponentials, and it was like on the first or second day we were like, this is so easy, and I told you it is easy, but don't forget the easy stuff when we learn harder stuff. Remember what happens when you have like bases. If I have like bases on exponents, what does that mean? They cancel out. They cancel out, and everything that's in the exponent drops to the line, and I usually have a really simple equation. In this case, my two bases cancel, and I end up with just x equals 6. It basically solves the problem for me. Well, logarithms and exponentials are inverses of each other. So because of that, if I have a base and an argument that are the same thing happens. So in this case, if you think of it this way, the p gets moved to the front, so this would be p log base b of b, and log base b of b cancels, and it leaves me just p. So in this case, I have log base b of b. Now there's nothing written up there as an exponent, but what is always understood to be there?
1.
A 1. So if the base and the argument are the same, it equals 1. It's not a log anymore, it is the number 1. That is it. And it doesn't matter what the base and the argument are. It doesn't matter if they're numbers, letters, symbols. It could be log base 2 of 2, and that would equal 1. It could be log base 5 of 5, that would equal 1. It could be log base pi of pi, that would equal 1. It could be log base t of t, that would equal 1. It could be log base smiley face of smiley face. And if the base and the argument are the same, it equals 1. Always and forever. Everybody good? That makes them super easy. Okay,
What if it's 0?
what's 0?
If they're both 0, then it's still 1.
1. Okay, so
Stupid, like,
try these first with, it says try these first without a calculator, then use the calculator with, it says with the decimal set, well, don't worry about this one, we'll talk about this later. Okay, so we're going to do the same thing that we're doing on the front, but we're just going to change it up each time. So I have log 2 and log 450, and I need to figure out log 900. How can I rewrite 900 with a 2 and a 450?
450 times 2.
450 times 2. So I'm going to rewrite this logarithm instead of log 900. I'm going to rewrite it as log 450 times 2. Is everybody okay so far? Now, that is an argument being multiplied. I could rewrite that as two separate logarithms being added. So I'm going to write log 450 plus log 2. what log of 450 is because they told me. Log of 450 is 2.65. That's the solution to log 450. So that means I could rewrite this as 2.65 plus log of 2 is 0.3, which means my
2.95.
final answer is 2.95. All right, so do B real quick.
Do we have to write it all out?
No, you don't have to write the whole thing out. All right, I got 1.82. Okay. Let's see, on the next one, C, I need to get 12, and they gave me 36 and 3.
Divide
So this time I'm dividing, and the order that they're in does matter. So
1.6.
log 36 divided by 3. So that's going to be log of 36 minus log of 3, which is 1.6 minus 0.5, which is 1.1. Everybody okay? All right, what about this next one? All they gave me was log 11, and they want me to get 121.
Squared.
Yeah, you could either do log 11 times log 11, or you could do log 11 times 11, or you could do log 11 squared. Either way, it works the same. I'm going to do squared just because we haven't done one yet. It's squared. Now, according to my log rules, anything that's up here in the tree house can be moved to the front as the coefficient. So that would be 2 log 11. And log 11 is 1.04, so that'd be 2 times 1.04, which is 2.0. Is everybody good? All right. Now we're going to rewrite these logarithms as single expressions. So right now it's 2 logs, and they're separated by addition, so I can put them together by multiplication. So that would give me log 10. Now, it's not written there, but that's common log, which is log base 10. So this is log base 10 of 10, which equals 1. Alright, got 2 logarithms separated by subtraction. So I need to put them back together with
Divide 500.
division. So I'm going to do log 500 divided by 5,
100.
which is log 100,
Equals
which I can actually write as log 10 squared. And if I use my log properties, 2 can move to the front, and that'd be 2 log 10 of 10,
equals 2.
so it equals 2. Does anybody have any questions? Y'all okay? All right. G, 2 logs separated by subtraction. I need to condense it into 1 log. Since it has an x in it, this one's not going to simplify, so it's just going to be log base 5 x over 10. And that's it. That's all you can do. So. On this one, I'm going to take my 2 and put it back on the argument. So that would give me log base 3 of x plus 1 squared. And now I'm actually going to go ahead and square that out, just because that's what you're supposed to do. So that would be log base 3 of x squared plus 2x plus 1. I'm going to do the same thing here. 3 goes back onto the argument. So that's going to be log 2m to the 4th raised to the 3rd power. So if I simplify that, that's going to be log 2 to the 3rd is 8. M to the 4th raised to the 3rd is m to the 12th. All good? Okay. Alright, so now I need to, on J, I need to simplify. So what should I do? Move 7 to the front. That gives me 7 log base 5 of 5.
You got me in trouble, boys.
So it's just 7. Because log base 5 of 5 is 1. So it just equals 7. So the next one I got log base 6 of 6. Just 1. Alright, so on this one I have negative 4. Move to the front. That'd be negative 4 log 10. That's log base 10 of 10, so this is just negative 4. Okay, so this next one is log base 12 of 3 times 4. Log base 12 of 12.
So it's 1.
What is 1? Are y'all okay? Alright, so there's some practice problems.
Wait, what was the, how was it 57? Oh, just the 5
Yeah. So there's some practice problems back here. They're pretty easy, but so they're always and forever going to give you a couple of these, but one that they will never give you, but they are going to expect you to use is log base and argument the same. They're not going to give it to you, but you might need it. Log base 2 of 2 equals 1. So even though they didn't tell me that, I can use that. So I'm going to give you about 5 minutes to see if you can work 1, 2, and 3.
When August is, thank God